This is part 5 of a series on building a full-stack web application using Spring Boot and React, where you get to watch every line of code being written and a full app built from the scratch, step by step. If you're new, start watching from this video. Alright, so far we've done the work to get data from a CSV file and load it into an in-memory database in a Spring Boot app. Now what's left is to take that data and expose them as REST APIs. So when we build our React front-end app, it's going to be able to make these calls and render the UI. So now the question is, what is the APIs that we need? Okay, so we're again going to map from the UI to the APIs. This is a bit of a controversial topic. Do you create APIs purely based out of the data and not consider the UI at all? Or do you look at the UI and have it inform your API design? If you don't consider the UI and just create APIs as pure RESTful resources, the advantage is it's going to stay the same even if the UI changes. But the disadvantage is you might have to make multiple calls from the UI to these REST resources to get everything that the UI needs. Okay, if you're not considering the UI at all, you just create your own resources. Well, now the problem is they may not be optimized for your UI. On the other hand, if you look at the UI and then build your APIs from there, as the UI changes, your API changes as well, or at least needs to change. And also, it's not RESTful and all that stuff. So it's a little bit of a balancing act. You need to make sure that you're keeping your resources RESTful and designing it well, but at the same time, not have it be too much of a load for the UI to make all these multiple calls to get what it wants just because you happen to design your APIs in a vacuum. I'm going to start out with the UI in this case because there's not a lot of stuff happening there. It should translate well to the resource as well. So let's start with the API design now. What are the API endpoints and what do we want them to return? So we're going to start with the team page, right? So you have the team dashboard page, which needs the team information, right? So we can have a /teams/team name here. Okay, so this is going to be our first endpoint. And what this is going to return is basically the team information. Okay, so it's going to return the team info, which is basically the team name, number of matches, win loss, and what else? Well, basically the top few matches, right? So we know that in the page, we need to show like the last 3 or the last 4 matches that this team has played, okay? So we're gonna have a list of last in matches, okay? So we're gonna return this. Now, the next thing that we need is the match page. What do we need over here? We want to do some kind of a classification so that we are not showing all the matches. We can maybe have like a year thing, which is one of the things we talked about. And then we show the one match and then the ability to kind of like scroll to matches before and after. And these are going to be matches for a particular team anyway. So this would need to be, I'm thinking, since it belongs to a particular team, I'll probably do something like this, /teams/team name /matches. And maybe the year selection can be a query parameter, right? Maybe we can have a year equals something like this. Okay, so this can be a query param, and then this will be the API, which is going to get all of the matches for that team for that year. And the question is now, if we don't supply this, do we return all the matches for the team? Well, we can decide based on, I don't know. Is there a use case for it? Probably not, because we don't want to show all the matches for the team. That's going to be a very intensive response. It's going to contain a lot of data, so we don't want to do that. So we can enforce the year and say this year is a required query param, and then get all the matches for that team for that year. Okay, so it's going to handle this UI. All right, so we have 2 API endpoints. Let's start by building those. This time I'm going to collapse this view and then choose the Java projects view, because this is actually much more easier to use for Java projects rather than the standard file view. So here you get kind of like this package-based view, which is handy. Either one works, but I'm going to switch to this one this time. All right, so what I'm going to do is create let's start with the team API. Okay, it's a team API which takes in a team name and then returns the team information. Okay, we have a team table. It's going to look that up and then return it. I'm going to create a controller package over here. Actually, I'm going to put this over here. Inside this, I'm going to create a new package called controller. And inside this controller package, I'm going to create a class called team controller. Okay, now what is this team controller class? It is going to basically create one API at this point, and we can add it to contain more. This is going to be a REST controller. Okay, from org Spring Framework, REST controller. And this is going to contain one method. Okay, it's going to be a public team. Let me call it get team. Okay, which takes in a string team name. Okay, and this will eventually return a team instance. Now this will be mapped to the URL by using get mapping, and then the URL that we're looking at is /team/ the team name, right? So I'm going to put the colon here, not the colon, it's the curly brace. Team name. Okay, so this is basically going to make sure that this is a parameterized thing. Okay, and now since I'm using this, I need to annotate this with a path variable, because I'm telling that this is a path variable, string team name. Okay, so it needs to take this value, whatever is this team name, it is going to pass it in over here. Now, here is my opportunity to basically get the data from the database, and I'm going to use JPA for this. Okay, JPA has the ability to, like with JPA, you can create these repositories where you define the interface, and then JPA infrastructure is going to actually create the code for it. Right? It's almost like you're creating a query using method names. So I'm going to do that next. So I'm going to call the repository and say, hey, repository, get me the team with this particular name, which is what I want. Okay, so what I'm going to do is I'm going to go to here. I'm not going to call it data. I'm probably just going to call it repository. Okay, I'm going to create a package called repository, and then inside this package, I'm going to create a class called team repository. Okay, this is actually going to be an interface. Okay, it's not going to be a class, and this is going to extend CRUD repository, because the CRUD repository is one of the base interfaces which allow this kind of like interface to actual magic to happen in JPA. Okay, repository, and this is going to be a generic type. What this is going to take is two types. One is the thing itself that you're fetching. In this case, it's a team. And then the second type is going to be the ID. What is the ID type? Okay, so the thing itself we are fetching is the team. And then the ID that we are fetching is of type long, because we have specified the ID to be of type long. Let me import everything. And now that I've imported this, I can create interface methods over here, which define what is it that we want. Okay, so for example, let's say I want to get all the teams that have a particular name. I can just say, define a method here, which returns a team. It's going to be a find by team name, and it is going to take a string team name. Okay, what I'm doing here is I'm defining a method, right? I'm not even defining a method, I'm declaring a method. And the way this works is Spring JPA is going to look at the method name to find out what the implementation should be. Okay, so if you say it starts out with find by, it's going to ignore all the things that until the by. Okay, the by is where it's going to actually start looking. Okay, from this point, it's going to start looking. It's going to be like, okay, what is it that I need to query for? It's going to query for team name, and what is it that it needs to return? it needs to return an instance of team. All right, so it's going to take this value, whatever you're passing to it, and then it's going to be like, I'm going to look at the team table and find all the team instances which have the same name as, which is basically team name, as what we have over here, right? Just let's make sure the name is team name. Yeah, so this is the field over here, right? So as long as I'm specifying that name, it is going to use this to query, and it's going to return me. Since I'm providing just one over here, it's going to assume that there's just one. It's going to return the first thing that it finds. If you feel that there could be more than one rows with that team name, you can specify a list, and then it is going to return all of them. And it's going to give you kind of like a list of teams, but that's not what we want. We know that every team name is corresponding to one row in the team table. So I can just specify, just get me a team instance, and then it's going to return the first thing, which hopefully is the only one in the table, right? We don't want multiple entries in the team. Okay, so now we have this interface defined. I can actually use this repository to make a call and get that information. Okay, so I'm going to use dependency injection here, and I'm going to use constructor injection, like you should. I'm going to create a member variable, private. Team repository. Gonna import this, and then over here we actually create a constructor with team repository as an argument, right? This is going to auto wire the team repository, okay? And now I can use this in my controller. Right, so I'm going to say, I'm going to get this team repository, which is basically an instance of a class of this type, team repository. And now I'm going to call this method, find by team name, and I can pass in the team name. Spring JPA would have done the work, right? It's written the code magically behind the scenes to query the team table and return a team instance where the team name matches this team name. So we should be good. So I'm going to do this dot team repository dot find by team name, and I'm going to pass in the team name over here, right? So now I can do return of this thing, and this should be it, right? This is our controller. Okay, so we have annotated as the REST controller, and we have a get mapping, so it should basically start off at that particular endpoint. Okay, so now what I'm going to do is I'm going to run this again. And let's open this up in a browser. Okay, so here's again localhost 8080, which doesn't have anything. So I'm going to make a call to localhost 8080/team/Chennai Super Kings, an example team. And when I hit enter, I get an error that says no default constructor for entity. Since we had a custom constructor for the team class, it doesn't work. JPA requires a default constructor. So I'm just going to go ahead and do that. I'm going to say source action constructor, and then just specify an empty constructor. I'm too lazy to type this. Yes, I had to do source action to get that there. Oh well. Now let's try running this again. I'm going to refresh, and now here we get the team. Okay, so I have ID, the team name, total matches they played, and the total wins. Okay, which is what we want. All right, so now let me do one more, right? So I'm going to do Delhi Capitals, and now I get that particular team. So we should be good to go, right? So we have the team API. Now, one thing that we talked about with the team API was to also get the latest matches that the team has played, okay? Maybe like the top 3 matches. Maybe the top 4 matches, because the UI that we had was we're going to have one latest match with a lot of detail, and then 3 more matches with kind of minimal detail, okay? So what I'm going to do is in my team class, I'm going to create a list of matches. Okay, this is not something that's going to be persisted. This is going to be populated after we are fetching the team data, but I just want to keep that there so that I can load all the match information, like the latest 3 match information, and send that over the wire. We need that for the UI, okay? So what I'm going to do here is I'm going to create a private, not the match, it's the team instance. All right. So along with getting the team information, I'm going to be having a member variable here, which gets the latest 3 or 4 matches, right? I'm going to have a list of matches here. And then what I want to do here is make this transient. Okay, now what does transient mean? Transient basically means I am asking, it's Java X persistence transient, this one, okay? I'm basically telling JPA, don't bother with this field, right? I'm telling it this is something that I'm using to send data to somewhere, right? This is not going to manifest as a database entry. And the way we are saving data right now, we don't really have like a primary key and a foreign key between teams and matches. If you want to do that, feel free to change this code and have that happen. But right now it's all based on team names, right? I don't have a team be an entry of team be a foreign key to a team name in the match table. Okay, it's just based on names. But at the same time, I want to add match data to the team response that goes over the wire as the API response. And I don't want this to correspond to like an extra mapping table in the database. That's the reason I'm just marking it as transient to say like, yeah, don't worry about this JPA. I'm just using this for my own personal needs and I don't need this to go into the database. So that's what this is doing. So I'm going to create getters and setters for this thing. And it should get added at the end. Yeah, it's added at the end. So this is good. Now what I can do is over here, when I get this, I'm going to not just return it directly. I'm going to populate those team values. Okay, so sorry, match values. I'm gonna get like the latest 4 matches from the match table, populate it, and then send the team information. Okay, so I'm going to say team equals. And now here I'm going to populate the matches and then I'm going to do return team. Okay. Now, how do I populate these matches? Well, of course, just like I use the team repository to get team information, I'm going to need match repository to get match information. I'm going to create a new Java class. I'm going to call this match repository. Okay. And again, this is going to be an interface. It's not a class. And then it is going to extend CRUD repository again, but this time the class that it's extending, the generic type is going to be match. Okay. All right. Now, what is the method that we need? This one's a little tricky because it's going to take a team name, right? You want to be able to say like get latest matches for team name. Okay, this is what you want. But then what is a match for a team? The team can be either in team 1 or it can be in team 2. Okay, so that's going to be tricky. So for example, if we're just looking at team 1, okay, if you had to get all the matches where team 1 is equal to the team that you're looking for, you can do something like this. You can say list of match get by, I'm going to say team 1, and then I'm going to do a string team name. Okay, so this is going to give me all the match instances where the value of team 1 is the team name that you're passing. Okay. However, we need more. We also need team 2. Okay, so this is where the power of JPA method names comes into play. You can actually kind of create like a SQL query right in the method name. Okay, so you can do something like this, or team 2. Okay, so now I have either if team 1 is equal to this or team 2 is equal to, now I have 2 fields, so I need to specify another field. I'm going to say string team name 2, right? I'm going to call this team name 1 and team name 2. And basically what this is doing is it is telling JPA, hey, get me all the matches where team 1 is equal to this first argument, or team2 is equal to this, the second argument. And then what I expect is not one match, it is a list of matches. So get me everything where these conditions match, okay? And how does it do this? Well, basically, again, it ignores the part of the method before the by, including the by, and then now it's over here, it is going to look at the name, the rest of the name, to identify the field names, okay? It's going to identify, okay, there is one field name, which is team1, and then another field name, which is team2, and then the condition is R, okay? Now it is going to expect you to provide the value for the first field. Team1 is going to be the first parameter, which is the string, and then field2, it's the second parameter, which is another string. So it is going to run a query where it is going to check field1 equals value1, or, which is the condition over here, field2 equals value2. It is going to do that and then put all those values together, and then it's going to return you a list. Okay, that's awesome, isn't it? So now I can make a call to this thing. I'm going to inject the match repository as well over here. And then I'm going to need to kind of auto wire this thing as well. Match repository, lowercase m here. And then I'm going to set the match repository. Okay, and import match repository. All right, value is not used. Well, we're going to use that in a bit. Okay, so now I've got the team. I can make another call to the match repository. I'm going to say this dot match repository dot, and then the method that we have, which is get by team1 or team2. Well, in our case, team1 and team2 are both the same thing, which is team name. Okay, so I'm going to just pass this thing to both the fields. Okay, so get me all the matches where team1 is equal to team name or team2 is equal to team name. Okay, it's the same team. And now I'm going to do a team dot set matches to be whatever this returns. Okay, and then I'm going to return team. Now what I'm doing is I'm basically getting everything, right? I'm getting all the matches. Okay, so this is going to be a huge list. It's basically getting all the matches of a particular team. Well, this is not what I want. There are a couple of things I need to do. First, I need to sort it by date descending so that it just picks the latest few matches. And then I need to basically set a page size and say, okay, give me only these many, not the whole thing. Both of them are possible in JPA, but using different techniques. Okay, first, let's fix the sorting part. Sorting is easy. Just like you have the conditions specified over here, you can also specify sort criteria by the method name. Okay, so I can say order by, and then the field name, and then the order descending if required, right? So what's the field name? We have called it, well, the match actually, we've called it date. Okay, so what I can do is order by date descending. And this is it. With this, I have sorted the results. Isn't this awesome? I'm basically writing SQL queries using method names, right? That's how these method names work with JPA. It kind of looks at the method name to infer what the response needs to be. So this part is fine. It should basically sort it now. Let's verify this. I'm gonna refresh this. I get an error. Okay, I need to update the method name here. So I'm gonna go back to the controller and I'm gonna update the method name to this order by thing. And now I should get this sorted by date descending. So 2020 is the first one, which is, 10/11/2020, and then 8/11/2020. So it seems to be in order of descending order of date. Okay, so this is good. Now we have tackled the sorting part. Now how do we tackle the get me the top 4? Okay, So there are a couple of ways you can do this. One is by using JPQL. You can use a query annotation and do this. But another way is to basically use like a page. Okay, you can have a page request passed in, right? You can say I want this to be only these many pages, and then you can get that. Okay, so let me show you how that works. So the default way of getting this information is basically the JPA is going to return you everything that matches. Okay, you have your query criteria in your method name. If it matches, it's going to return everything. Okay, so you have to tell JPA, hey, hold on, I don't want everything. I just want these many records. And you can do that by telling JPA that this method needs to be pageable. Okay, you're going to say, okay, I don't want all the records. I want page by page. Okay, the way to do that is by sticking we go to the match repository here. The way to do that is by basically sticking a pageable parameter to this thing. I'm going to say the last parameter is going to be pageable. I'm going to call this pageable. Okay, pageable is a Spring Framework data domain class, which is basically going to say, okay, I want this particular method to be accessed page by page. I'm going to specify how much is the size of the page, and you're going to give me only the data for that page. Don't give me everything. Okay. And now what I can do is I can call this by specifying the page size. All right. Now here, I can't just specify this alone. I'm going to need to specify the page size. I'm going to say I'm going to create a new pageable pageable equals, I'm going to say page request. Let's say I want a new page request dot off, and I can specify the page number and then the page size. I'm going to say the page number is 0 and the page size is, well, I want, I don't know, 4. Okay. And now I'm going to pass this to the method pageable. So basically saying I'm going to get this data. I want this data. Here are all the arguments. And then I'm also specifying the page size. I'm going to say, get me page 0 with a page size of 4, which is basically the latest 4 matches that were played. So now if I reload this page, I'm just going to get the last 4 matches. All right. So here you see 0, 1, 2, and 3. So I have created this pageable method to make sure that it doesn't give me everything. It just gives me these many numbers. One optimization I can do is, so here's the thing. This is not ideal because what is this class? This class is a controller, right? It's kind of like the C of the MVC. All right. And what is this class that we're using over here? Page request pageable. This one is from data domain. Okay. So now we have data domain classes syntax in the controller, which is not ideal, right? You want to move this to your repository and have the controller just be dependent on your repository and not on other data related stuff. Just a best practice not to have them be so tightly coupled. So what you can do is basically move this into the repository. Okay, create a method in the repository and then have it do this, basically create the pageable and then call this method. And then your controller is going to call that guy. So your controller is not going to have to deal with the page request. It's probably going to just send like the page count. And then this is going to figure how many, what's the start of the page and all that it has to do. You might be wondering, well, hang on, Kaushik, how can you create a method here? We have, this is an interface, right? How can you create a method in an interface? Well, you can, because you can have a default method, right? Java has the ability to create methods in interfaces now by using the default keyword. You can create a default method in an interface, and that is going to be a part of the interface. You don't have to create a new class for this. I know some people like to create their own DAO classes, which is going to call the repository. And that's meant to do stuff like this, right? It's going to contain methods and it's going to call the repository for like this kind of crazy method names, which they don't want to call from the controller. So the DAO class is an intermediary which maps it to crazy method names over here, but that the controller calls with some reasonably sane method names. You can do that if you want, but you don't need to do that because now Java does support creating methods, implementations of methods in an interface. So you can create like a default method over here and have that call the repository method. Okay. So here's what I'm going to do. I'm going to create a default method and this is going to return a list of matches, right? This is what we want. It's going to create a list of match and I'm just going to call this find latest matches by team, which is a sensible name, right? It's better than what I have over here, right? And this is going to take 2 parameters. I'm going to call this string team name, which is which team do you want, and then I'm going to accept like a count. How many matches do you want? Okay, this is reasonable. Find the latest matches by team, give it the team name, and give it the count. And what does this do? It basically returns this call. It's going to call this guy, and it is going to prepare the parameters. Okay, what is the parameter it needs? First parameter is team name. What's the second parameter? That's also team name. And then the third parameter is pageable. So I'm going to do a page request dot off, which is basically what I did over here, right? What I had in the controller is now going to go to my DAO/repository so that I don't have to make that call from my controller. And the size is going to be count, which is what I am passing from the controller. Okay, import page request, and now this method is over here. Now that this is over here, I don't need to import any of the data stuff here anymore. What I need to do instead is just call this method, all right? Team name, and then just give me the last 4 matches. This is much more elegant, isn't it? I'm basically calling this nice method, which has an intuitive name. I know it's the method names are powerful, right? In the repository, this is really cool that you can do all this stuff. You can basically create SQL statements as method names and get that done. But this kind of makes it a little more elegant. You kind of get an idea of what this is doing without having all the details about the tables show up in the method name. So this is it's a nice thing to do. All right, so this should work pretty much the same as what we have seen earlier. I cleared out the imports, so we don't have that kind of an overlap of data stuff showing in the controller. And now if I were to refresh the page, it should basically show the same result. We have this kind of in a more elegant way now. All right, so now we have the team API. It has, it takes in a team name, and it returns the team information. What information does it return? It returns the total matches and then the total wins. So we can show kind of like that win percentage on the right-hand side. And then we have the number of the last 4 matches. So we can have like a big match display below, which takes up the whole width of the screen. And then we can have 3 small tiles below it, and then a more link which doesn't need data. Okay. Now we have a couple of options. We can either move on to creating a front end, right? Creating a React app that consumes this API and get the team page working, and then move on to the match page. Or we can create the match API and then create the team, create the front end all together, right? Including the team page and the match page. I kind of like creating the team page first so that we can kind of get a sense for if this is working fine or if we need to make any changes. So rather than go all in and complete all the APIs, I like to work with, the mid-tier, get the API working and write the front end, get that working, and then iteratively develop both. So I'm thinking it's time for React now. We're going to create a React app and kind of consume this data. What do you think? Yeah, let's do that next.